Good afternoon, everyone. Let's see now theorem number 17. Okay, what is statement of theorem number 17? If A and B are arbitrary distinct elements of a group G and H is any subgroup of G, then we have to show these two parts. HA is equal to HB, means right coset of A is equal to right coset of B if and only if AB inverse belongs to H. H is a subgroup. Or left coset of A is equal to left coset of B if and only if B inverse A belongs to H. So let's see first part. Okay, first part. First proof of first part. Let take two elements from set from group G. A and B are the elements from group G such that A not equal to B. Yes, and E be the identity of group G. Hence E belongs to H. H is a subgroup, so H also belongs identity. Yes, assume that. Means we have to take now first part. Yes, H right coset of A is equal to right coset of B. Multiply both sides by B inverse from the right side. B inverse belongs to G, because if A and B belongs to G, so A inverse B inverse also belongs to group G. Understood? This implies H AB inverse is equal to H BB inverse. BB inverse means identity is equal to H. So we will get what? H of AB inverse is equal to H. What is the meaning? By theorem 16. This is the statement of theorem 16. Theorem 16 says that already we have seen video on this theorem 16. Yes, H of AB inverse is equal to H means what? We can write by theorem 16 AB inverse belongs to H. Yes, so now let's see the converse part of this first part. Okay, so take AB inverse belongs to H and we have to show right coset of A is equal to right coset of B. Understood? So let AB inverse belongs to H by theorem 16. Yes, take reverse step of this part first. H of AB inverse is equal to H. Multiply both sides by B. In above step we multiplied by B inverse. Now here multiply both sides by B. Yes, so you will get HAB inverse B is equal to HB. So BB inverse is identity. You will get HA is equal to HE. HB means right coset of A is equal to right coset of B. And here we ended our proof. Yes. Okay. So what is second part? Proof of second part. See. Exactly same, but only here they have given right coset of A is equal to right coset of B, and in a similar manner we have to prove in second part left coset of A is equal to left coset of B if and only if B inverse A belongs to H. Yes, same steps are made here, no changes, only take left coset of A is equal to left coset of B. See the proof. Yes. Okay, let's see theorem number 18. Theorem number 18. Okay, what is theorem number 18? Any two right cosets of a subgroup are either disjoint or identical. That we have to prove. What? Take two cosets, right cosets or two left cosets. Take any two right cosets or take any two left cosets. Yes, and we have to show that their intersection is either disjoint or identical. Okay, so write the proof. Let H be a subgroup of a group G. Yes, of a group G. Let HA and HB be two right cosets. Okay, be two right cosets of H for A, B belongs to G. A and B are two elements from the group G. Yes. For these cosets, we have either what we have to show, intersection of these two cosets HA and HB is either empty or yes, or HA intersection HB is not equal to same empty. Yes. What we have to show that? We show that HA intersection HB is not equal to 0. Yes, is not equal to 0. This implies what? HA is equal to HB. Yes. Suppose that intersection of these two right cosets is not equal to 0. Yes. This implies there exists. This is the sign of there exists. जर ह्या दोघांचं इंटरसेक्शन एम्प्टी नाही तर त्यामध्ये कमीत कमी एक एलिमेंट असलाच पाहिजे. येस. सो टेक x belongs to means any one element belongs to this intersection of these two right cosets. Yes. So this implies intersection मध्ये आहे म्हणजे means what? x belongs to HA and x belongs to HB. Yes. So this implies there exist H1 and H2 belongs to subgroup H such that x is equal to H1A, x is equal to H2B. दोन्ही राईट कोसेट मध्ये कसे एलिमेंट असतात? ह्या टाईपचे एलिमेंट असतात. हे आपण डेफिनेशन मध्ये बघितलं आहे. H1A, H2B अशा टाईपचे एलिमेंट्स असतात. सो दिस इम्प्लाइज व्हॉट? लेफ्ट साइड इज सेम x. So right side must be equal because left side, given that left side is equal. So H1A is equal to H2B. Yes. So this implies multiply both side by H1 inverse. So you will get H1 inverse H1A is equal to H1 inverse H2B. Yes. So H1 inverse H2. Here H1 inverse H. So here we get final step is A is equal to H1 inverse into H1 is identity. So EA is equal to H1 inverse H2B. Yes. See. E means identity. So the above step we can write A is equal to H1 inverse H2B. Yes. But H1 and H2 belongs to H. So this implies and H is a subgroup. So we know H1 inverse H2 belongs to H because subgroup H1 inverse H2 satisfies the definition of अशा प्रकारचे एलिमेंट हे H मध्ये असतात. ए बी इन्व्हर्स किंवा बी इन्व्हर्स असे आपण बघितले आहेत. येस. सो H1 इन्व्हर्स H2 बिलॉंग्स टू H. देन H1 इन्व्हर्स H2 is equal to H by theorem 16. Again use here theorem 16. Write down the statement of theorem 16 here. Yes. So from above equation, yes, call this as suppose equation 1. Okay. So from above equation 1 we can write HA is equal to H1 inverse H2B is equal to H1 inverse H2B is equal to HB. since h1 inverse h2 is equal to h. So this implies HA intersection HB is equal to empty, or we can write HA is equal to HB. Yes, here we ended our proof. Thank you.